Okay, so good afternoon, everybody. Can you all hear me
Afternoon.
well?
Afternoon,
Yes,
sir.
sir. Yes, sir.
Okay, great. So look how fast 4 days pass. Well, today's the fourth day. So fast time goes. So you need to be studying every day, not only for maths, for the other subjects you may be writing, okay? Try to give everything some attention. All right, so today is the our final session, and we had made it up to question 8 last day. So we still have a bit of question 8 to do, and we'll look at number 9 and 10. Now, the thing is, if you all ever try doing a past paper under exam conditions, you would realize that you kind of get a little tired coming down to the last few questions. And the problem is, though, that those questions require you to put a lot more thought into it. So some students tend to they tend to choose to do those last questions first and the easier questions last. So that's a technique that you could try if you find yourself running out of the energy and the mental capacity to deal with these types of questions. Right, so let us start. Right, I'm going to share and we're going to continue. Okay, so that's now. Let me know. It should be working now. Okay. All right, so you all should be seeing this. Okay, just not. Two more documents open. Just slow down the program. I'm going to close off what I don't need. All right, so just now I'll share. Right. Well, I have so much copies of the same thing open. Right, so this is what I'm going to show with you. Let's begin the process. Right. So last day we stopped on the inequalities question, right? And there was a other part to number 8. And thankfully, part B is much easier because part B is diving into quadratics. And well, this particular question, they gave us these coordinates here. They give you a big help. I'm sure some of you may have encountered questions like this where they give you a certain function within a quadratic equation, and they may give you some of the x values, and you will have to figure out the y values by substituting the x value into the equation to figure out the y value. I'm not sure if anybody's seen questions like that. Did yours ever see a question like that? Right, that's what you're more familiar with. Right, but let's look at what's going on here, though. They gave you the table already, so they kind of give you a big help. So they give you this table, and this is coordinates on the curve of this function here. Y is equal to x squared plus x take away 4. Let me make sure I'm recording everything. This not right, so I just want to double check everything is working here. Right, so this is our quadratic equation. We have some points, and they want us to plot this graph. We'll plot the graph just now. Let's read what else they have over here. On the grid provided on page 25, plot the remaining 4 points. So they actually plot some for you. You just need to plot the last 4 points. That's so easy. And draw the graph. All right, and this is the graph here, the graph of this particular equation. What does this mean? Minus 4 is less than and equal to x, which is less than and equal to 3. What is this? Anyone knows what this is? Or how do we interpret this? That's a better question. Because this is this could be a multiple choice question, and indeed it is a multiple choice question. They could give you something like this and ask you they'll give you some options below, and you have to state what this actually is. Anyone wants to volunteer answer to this thing here before I explain it? What is this?
An inequality.
All right, so it is an inequality. Very good.
It could mean that the x on the x axis, the x is less than 3 or equal to 3.
Less than 3 and equal to 3. Yeah, x could be less than 3 or equal to 3. That is a possibility. That is not inaccurate. That is correct. but it has more. It means that you could go into a little greater description of this.
And x is more than or equal to -4.
Very good. That is the full definition. So if you ever see something like this, let me explain how to read this. Okay, this x here in the middle that we are seeing, x is, you know, if you read this sign, right, this particular sign here, this sign, if you read it in this direction, this is read as x is greater than or equal to 4, -4. That is how you could read this as well. Instead of 4 is less than or equal to x, you could read it as x is greater than or equal to -4. So if you look at the top of this table, this inequality basically gives us a range of values for x. That is what it does. It gives us a range of values for x. So it tells us that x, which, and notice these are all our x values here. X could be any number between -4 and 3. That is how we interpret this, okay? X could be any of these numbers between -4 and 3. So if we're looking at the numbers on the top here, we have all of these numbers, and notice that these numbers are -4, -3, -2, -1, 0, 1, 2, 3. These numbers are basically between 3 and -4. And because they have the equal sign here as well, x is greater than or equal to -4, we also include -4. Because x is less than or equal to 3, we also include the 3 as well. So next time you see this, this is simply all the numbers that exist between the 3 and the -4, and you must include the 3 and the -4 as well. So that is what this here describes the top row of this table. So a lot of people would just ignore this. They wouldn't even look at this and to interpret it. So I just wanted to spend a minute describing what we actually see in here. All right, so that being said, let's plot the curve now. So let's see what they gave us to work with. They plotted all the negative values here, all the negative x values. They plotted, notice, let me use my mouse, -4, -3, -2, -1. So they plotted all the negative values. What we have to do now is plot the rest, the remainder of the values here. So they already did us a solid and plotted these points here for us up to here. We need to plot these last 4 coordinates. So what we're going to do is look for 0 on the x-axis and -4 on the y-axis. Okay, I want you to remember that. 0 on the x, -4 on the y. So here, where would that coordinate be? 0 on the x-axis, -4 on the y. So that would be this point here. Right, so let me just neaten up this a little bit. Right here. Okay, that would be this point. Notice it's 0 on the x, this x-axis here, it's 0 on the x, and -4 on the y-axis. Moving on to the next point quickly, we have 1 on the x and -2 on the y-axis. So where would that be? That would be somewhere here, because this is 1 on the x-axis. Up here is the x-axis. 1 on the x, -2 on the y-axis. Okay, so moving on to 2 on the x and 2 on the y. So that's easy. Where would that be? 2 on the x is here, 2 on the y is here. So these two lines would meet at this particular point right here. Right, so I'm not drawing it the dot too perfect, but you all get the idea. The last one is 3 on the x, 8 on the y. So let's do that now. 3 on the x is here, 8 on the y is quite up here. So we go all the way up and we plot a point right there. So these are the remaining 4 points that you needed to plot. And now all you have to do is draw a curve that touches all of these points. So because I'm not using a paper, this is going to be a little tricky for me. Okay, so let's see how if I could draw this thing. So you just wanted to, it wouldn't be perfect, it would just touch most of it. Actually, let me don't draw it so thick. All right, so let's just draw this line. I'll draw it like this thickness. Yeah, that thickness good. So let me fix this. All right, so yeah, you'll get the idea, okay? It's a curve. It's not a straight line. So this tells us something. There's a name for these types of equations that gives us curves rather than straight lines. They are called non-linear equations. Did you all know that? Non-linear. Have you ever heard of a non-linear equation before?
Yes, sir.
Okay.
Yes, sir.
So linear, very good. Linear equations, when you plot them, you end up with straight lines, okay? Straight lines. What is a characteristic of a linear equation? So, well, the characteristic feature is that if we have the equation of a straight line, the power of the x there is always 1. But for a non-linear equation, notice we have a power of x that is bigger than 1 here, 2. So that is how we could tell if a line is going to be straight. If you plot this equation of this line, if it's going to be a straight line or a curve of some sort, you look at the highest power of x or the variable. If the variable has a power of 1, it's a straight line. The minute you see the variable having a power like 2 or something, you know you're going to expect a curve. And once we see a power of 2, we instantly know we're dealing with a quadratic equation. All right, so that is something that I just wanted to say there. It's not necessary for this question. That's just a little background theory. So now that we plotted this for 3 marks, they want us to write down the maximum or minimum value. What do they mean by a maximum or a minimum value? Anyone wants to tell me? What is a maximum or a minimum on a quadratic equation?
Is it that way the gradient, there's no gradient?
Not necessarily.
The curve stops at
Oh, yes. I understand. Yes, that is exactly true now. I understand what you were saying. Very good. Yes, that's a very technical answer, actually. That's a nice answer. So let me explain what a maximum or minimum is for students before we continue with the question. So let's say you have a graph like this. Okay, we have a graph. This is our y-axis. This is our x-axis. Let's say we were to plot a quadratic equation and we end up with a U-shaped curve like this. The minimum, this graph, which you're looking at here, the sketch, only has a minimum. It will not have a maximum. And the minimum will be the coordinates of this point down here. And sometimes you would hear people calling this the turning point or the critical point of some sort. That is where we stop going down and start going upwards. So that is the minimum. The coordinates of this particular point at the bottom of your curve. Sometimes when you plot quadratics, you may not end up with a curve looking like a smile. Notice this curve is looking like a smile, right? A smile. Sometimes you may end up with a curve looking like this. This looks like a frown. Okay? So you could have... Sorry?
It is a maximum.
Very good. So this is if you have a plotted quadratic and it looks like this is not a minimum. This is now the maximum. And the turning point up here is your that is the value, or that's the maximum value in this quadratic when you plot this graph. I'm going to tell you something that you may not know. You could look at a quadratic equation, just looking at this equation, and you could predict if it's going to be a maximum or a minimum. You don't need to plot it to tell. You could just look at the equation and know. Does anyone know how to tell by just looking at the equation? Let me see if anyone here knows this. This might be an AdMath student might answer.
More than
Mhm.
zero, that's a minimum.
If x
So
is
I think it's the sign of the
gradient
first
then.
coefficient.
If the gradient is negative
fine.
or positive, it determines it.
okay, right. So we got a lot of answers, and some of those answers were correct there, but I don't know if the students would understand what some of you were saying, but they were correct. I picked up on it. Two of the answers, I think I heard you, but two definitely was correct. You could tell if a curve is going to be a maximum or a minimum based on the sign. I will say sign because students would recognize positive and negative easily, right? So if you look at the sign of the coefficient of the x squared, that tells you if it's going to be a maximum or a minimum. So if we're looking at this, what's the coefficient of this x squared right now? What does coefficient mean? That's the number in front of the variable. So what is the sign of the number in front of this x squared? You mightn't see a number, but it is always have one there. Positive. Very good. When you have a positive coefficient of x squared, you are always going to end up with a minimum. That is why we plot, when you plot the points, what kind of curve did we get here? A maximum or a minimum?
Minimum.
A minimum. Okay? So that is the thing. Let me remove this from here now. So if the sign, again, if it's a positive value for the coefficient of x squared, you get a minimum. If it's a negative value for the coefficient of x squared, let's say you had negative 2x squared in your quadratic, you will definitely expect to get a maximum. Okay? Are you understanding this? This is just some extra stuff. You don't necessarily need to know this, but I think it would benefit students to help break down the stigma of quadratic equations, especially graphing them, if you have an understanding of basic properties like this. Looking at the sign in front of the coefficient could tell you if you're getting a maximum or a minimum. Because it's a positive, in this case, we definitely ended up with a minimum value. Right, so with that being said, let's figure out the coordinates of the minimum now. So we have our curve. Let's see if this. The minimum would be this is where your drawing would kind of have to be good. So mine is not too perfect, but because this thing tends to be, these quadratic graphs tend to be symmetrical. If I have a point here and a point here, the middle is supposed to be around here. This would be my minimum point. So if you notice this minimum point, let's see if we could figure out what the coordinates of this minimum point might look like. So what is the x coordinate of this point? Can anyone help me find the x coordinate? Average. It might be perfect because it's a bad drawing. In the exam, you will take your time and draw it carefully. You'll erase it and fix it as you need. What is the x value corresponding to that coordinate? What do you think it's looking like there? Look at this. Look at the top here. What is the x value? This line? 0.5. Very good. So the x value always goes first. So it's going to be around half or 0.5. 0.5. And what is the y? What that's looking like to you? The y coordinate. 4.1. Right, -4. Well, to me, it's looking like -4.12. Let me see how it is. Between, we have 5 blocks. So this will be 2.2, 2.4, 2.6, 2.8, and then 3. So each block is 0.2. So this might be in the middle here. It's looking like in my drawing, it's like in the middle. So that might be 4.3-ish in my drawing, okay? If you're looking at how you're doing the drawing, it will be in the middle there. You cut across, it's in the middle of the space. So this is around 4.3. All right, so it will vary depending on your value. Oops, why am I erasing that? So it will be 4.3. All right, so let me put that in here. Comma 4.3. This is the coordinates of your minimum point. And that is what you would put.
So it was max.
For the negative,
Oh yes, yes. Actually, it is a negative there. I know. Yeah, it's a little blurry, but it is negative, right? So I forgot my negative sign. See, I'm busy talking about it and I forget the negative sign. So you would lose marks if you forget the negative sign, like what I did. So learn from this. But the comma in a different color. Okay. So it is negative 4.3, and this is negative 0.5. Remember, this is on the negative side here. So it's both of them are negatives. Okay. You're seeing it, right? Both of them are negative numbers. That would be your minimum value. So that's it. Is there anything else? Using a ruler, draw the axis of symmetry. What is the axis of symmetry? Anyone ever heard of that before? What does symmetry mean? Very good. We're just going to draw a line that cuts this shape into perfect halves. That will actually be which part you see the point here of the minimum. If you draw a line going straight up from this point, that will be your axis of symmetry. So let me try my best to draw up axis of symmetry using this screen.
So basically it will be the x coordinate.
The not necessarily the x coordinate, because it's a line you are drawing. So because it's a line, remember lines have equations. So I can actually ask you all, this line that I drew here, what is the equation of this line? If this line could go on forever up and down, what would be the equation of this line? And yes, that's a valid question I could ask, because we saw equations of straight lines like these 2 days in a row. Can anyone tell me what would be the equation of this line?
X is equal to minus a half.
Very good. That is correct. If you have forgot how we figure that out, this will be x is equal to minus a half. This is the equation of the axis of symmetry. Okay? So, moving on. That's it. That's it. You don't need to put that equation. By the way, I just wanted you to know you don't need to really put that. You just needed to use your ruler and draw it. You just needed to draw it. Now, with that being said, this question is done. I wrote the answer for this under the graph where we put the coordinates. So that would be where you find the answer. Oh, by the way, I wanted to point out something. I had, in this document, remember that there were this question we did yesterday. I give you all one to try for homework. I have the solutions here, right? I drew the shape, and regarding the table, I have the answers here, and you all could take a look at this and compare it to your answer and make sure you get the same answer, right? For those who did this question, this is it, right? So that's done. Now that we finished number 8 entirely, let's move on to something that you all are excited about, number 9, okay? So unfortunately, in an exam, under exam conditions, students tend to be mentally exhausted by the time they reach circle theorem questions, so they don't focus on it carefully. And that is what causes issues. I don't think I met any student who says they really like circle theorems, okay? It's just one of those more difficult topics. It's not really a formula you could just apply and solve an equation of some sort, right? It's not you require you to remember a few theorems, and then you need to spot patterns, etc., inside your shapes. Not just and also this question, you need to remember triangle properties, line relationships with each other. For example, if you have a triangle like this, right, and these two sides are equal to each other, what would be the relationship between the angles in this triangle? This is what type of triangle if these two sides are equal to each other. What's the name of this triangle? An isosceles triangle. And are we seeing an isosceles triangle in this diagram? Can anyone spot it?
Yes, sir.
Right. Very good. Another thing you need to know is relationships between lines. Okay, that is important. Parallel lines. Like we have these two lines here. Let me just draw these two parallel lines for you. All right, these are two parallel lines. If I have a line basically intersecting these parallel lines, we have angles being formed all over here, right? All here we have angles being formed. The question is, we have to know the relationship between those angles. When we have parallel, then you want to talk something to say? When we have parallel lines like this, and we have a line cut in it, what's the name of this line? Anyone knows?
That want to be alternative angles.
Alternating angles. No, it's talking about
Transversal.
the transverse. That's it. Actually, yes, because I was looking for the name of the line in particular, right? So the line is called a transverse or the transversal, right? So anyone you could call it, but it's a transverse. That is what we call that line. And let's see if we could figure out some properties of this, right? Because this is going to help us with this question. Let's say that this, I'm giving you this, this is like a revision of the relationship of lines. These lines are parallel to each other. Let's say I tell you that this angle here is 30 degrees, right? Can you figure out what this angle here would be? Let's see. Take your time.
150.
How did you come, right? And how did you come to that answer?
180.
Angles
Straight line.
one.
So it's a
Because
straight line.
it's a straight line. Very good. I want you all to think about these things here. Properties of lines. That is what we analyzing in this question. Now, this angle here, what would this angle be?
30 degrees.
30.
Very
30.
good. Because these two angles
Yeah,
are
opposite.
very good. They are opposite and they are the same. Okay? They are the same. What would this angle down here be?
150 degrees.
150 degrees.
Very good. 150 degrees. And if we were to add all of these angles up together here, how much would we get?
260.
360.
Excellent, right? So for some of you, you might find this real easy, but I'm going to show you how this same easy concept could be tested much more difficult, right? So let's take this information now. Using the same information, what would be this angle? Let's see who following along.
Because Eliza.
30.
30.
No, let me show you how we can figure that.
150.
Oops, wait, just now. I'm just going to erase these things temporarily. You see this Z shape what we have forming in the middle here? You see it's like a Z? I'm going to try to draw it for you. So it's like a Z, right? In the middle here. If this angle is 30 degrees, this one here is going to also be 30 degrees. Okay? That's something I want you to remember, okay? 30 degrees. And if this angle is 30 degrees, down here is also going to be 30 degrees. And I remove this one, but let me put it back. This is 30 degrees as well. So look at this, try to remember that. Look at the pattern we have here. These two angles are the same, these two angles are the same. That is how it works. The same is true for these sides. You'll see. What was this big angle again? You all could remember it. What was this one?
150.
This was 150 degrees. This big angle down here is also 150 degrees. This big angle here is going to be 150 degrees. And the big angle down here is also going to be 150 degrees. Right? So this is something that students don't really remember, but I have put this here because this is going to help us with our question. So I'm going to erase this, okay? Because we understand the concept, but we need to move on to the question. Now, can anybody here spot that transverse and parallel lines in this shape? That same thing we just drew is right here. Can you see it?
Yes, sir.
Right.
Yeah.
If you cannot see it, just say something. And if anybody is monitoring the YouTube,
I can't see it.
right. So that you see why this is a difficult topic, because it is very difficult to spot the easy concepts. Let me show you. This is one. Whoops. this here is one of the parallel. Whoops, just no. I'm gonna make this marker a little thicker. Change color. This is one of the lines, the parallel lines, and this is one of the parallel lines here. They are parallel to each other, and this is the transverse in the middle. Can you see it now?
Yes, sir.
Right. So with circle theorems, it's easy concepts, but it's difficult to spot. Now, with that being said, let us quickly review some circle theorem concepts. I have a document I just took from the internet here, right? I'm going to only go through the ones that is beneficial to this question, but these are all circle theorems that you should try to remember, okay? Now, this one on top here is anybody want to try the 2023 paper? The 2023 circle theorem question is basically this alternate segment theory. So take a look at it. When you're studying, the 2023 paper uses this concept, okay? It combines this alternate segment theorem with angles in a semicircle. That is a hint. For anybody who wants, after this question, they want to study the 2023 circle theorem question, the hint is alternate segment theory, angles in a semicircle. Let me kind of explain some of these things that is going to help us now. So for our question, what we're going to analyze, 3 of these theorems are important, right? The 3 theorems that are of importance is this one here, angle in a semicircle. What this is, that if we have a diameter line, this black dot is the center of the circle. This green line is a diameter, okay? It cuts the circle into 2 halves. One half is a semicircle, the other half is a semicircle. If you were to draw these 2 lines and they meet at the circumference, at any point on the circumference, the angle, these 2 lines must meet at any point on the circumference. The angle formed between them is always 90 degrees. Therefore, this angle, which is inside of this semicircle, is always 90 degrees. That is something that we're going to see in our question just now. Right, so with that being said, let us answer the first 2 questions. As I need to show you a theorem, we'll go back to this document. So we'll alternate back and forth. Can anybody see that in this? Where's the diameter? What can anyone call out the name of the diameter line here using the letters you see?
MK.
MK.
Sir.
MK.
Right, so MK is our diameter. All right. That's not MK is our diameter. And isn't these 2 lines up here meeting at the circumference?
Yes, sir.
Yes, sir.
So what would this angle be on the circumference? Wouldn't that be 90 degrees?
90 degrees. 90 degrees.
Right, so that is something I just wanted to point out, right? Right, I just wanted to point that out. So let's just answer the first question here now, right? Before we move on, that's before we go back to analyzing. You're seeing how you can spot your circle theorems hidden inside this tangle of lines. So let's answer the first question. They want us to explain, given a reason, why angle HJM is 38 degrees. HJM. Where is HJM? So listen to how to interpret that. You start from H, you go to J. Let me use a ticker point. You start from H, you go to J, and then you travel to M. So this is the angle they're looking at here, right? So I'm removing the tick lines, and I will draw in this angle with this red marker. 10 point. I have to write 10. Hopefully you will still see it, because there'll be a lot of writing on this here. This is the angle we are interested in. Didn't we just figure that angle out, actually? If you all forgot, let's look at why. Remember, this is a parallel line here. HG is a parallel line. MK is a parallel line. And this line here is a transverse. So once we have this transverse intersecting these 2 parallel lines, this angle is going to be the same as our angle of interest. So you'll understand why our angle of interest is 38 degrees?
Yes, sir.
That one easy, right? That is 1 mark. So I'm going to write 38 degrees inside this thing somewhere. 38 degrees. Okay? I don't want to make the diagram too untidy. So I won't write anything, but I believe you all should understand because of the interest of time, I want us to just explain the question. Right, so let's look at MJK. Okay, where's MJK? Let's see. Let's see where MJK is. Right, so let's use a take a point. This is M. Oops. M to J to K. Wait now, but this is the angle we just now figure out. Remember this one? We just saw that. That's the right angle.
Yes,
Okay,
sir.
we just explained that. That's called angle in a semicircle. That is the one we just looked at, right? And that is 90 degrees. So you all understand why this one is 90 degrees as well?
Yes, sir.
Yes.
That one easy, right? This is angle in a semicircle and it is always 90 degrees. So I'm going to include that in my diagram as well. Anything you figure out, always put it into your diagram. I'll make it a little smaller. Okay, so this angle here is 90 degrees. It will help us to fill information in. So that's part 1 and 2. The next part of the question, they want us to figure out these 3 angles now. So I don't need to read the angles, because if you look at the diagram, do you notice that there are 3 angles that they give you in this diagram without writing anything? They give you here. Let me just use a ticker point. Here. They give you down here, and this little angle here. That is the 3 angles that we need to figure out now. Okay? You all following so far? That's the 3 angles that we're going to have to figure out. So, with that being said, how are we going to begin to figure out this particular thing? All right, we have to try to figure that out. How are we going to figure this out? Anyone has any clues? Any ideas?
Sir, add 38 plus 90 equal 180.
28 plus
So the 38 plus the 90,
mhm.
and then you take 180 and you minus that from it, and you'll find angle MKJ.
Okay, that is true, MKJ, right? But let us look at one thing as well here too. I want to bring up this particular theorem because I'm seeing a lot of it here. I'm going to draw it here first, and then we're going to look at. Just look at these one more theorem here. Look at the shape I am going to draw. What shape is that? How much side?
Quadrilateral.
Quadrilateral.
It's a very good. Now, using your imagination as well, what shape is this? Just stick with the general names like quadrilaterals. What is this?
So the same thing, sir.
It's a quadrilateral. Very good. There are 2 cyclic quadrilaterals here. So let's just review what is a cyclic quadrilateral. So that's down here. Have you all ever heard of supplementary angles?
Yes.
Yes,
Yes,
sir.
Right. Basically, okay, what that means is in a quadrilateral, like a square or a rectangle as an easy reference, opposite angles will add up to 180 degrees. So this angle in yellow, add this angle down here in yellow, must add up to give what?
180 degrees.
180 degrees. So that is an important circle theorem that I want you to also remember. That is very easy to remember, actually. It's not hard to remember. This is called a what? Cyclic quadrilateral. Okay? Cyclic quadrilateral. So let us see what else we can do now with this question. Let us go back to the question. That is, oops, how did that happen? Right, so I'm taking my time with the circle theorem. We can speed up with the other one. Let's take our time with this. Now that we know that, don't we know, I want to draw a cyclic quadrilateral here, and I want to point something out to you. Let's draw this quadrilateral here. Right? You're seeing it, right? Don't we know, don't we know this? Let me draw it a little neater because it will be easier to see it. Right, so let's look at this. Remember the properties of a cyclic quadrilateral.
All
Yeah.
angles.
Don't we notice angle?
Yes, sir.
Yes, sir.
Yes, sir.
What was that angle going to be? Isn't that the sum of 38 and 90? Because we just figured that out. This angle down here is 90 degrees, and the remainder here is 38. So this whole angle is the sum of 38 and 90. You all agree with that?
Yes,
Yes, sir.
Anyone don't understand that? Let me know. This portion we figured out was 38, and this portion here we had figured out is 90 degrees because that's this angle in a semicircle. This portion here that I'm covering, that's 90. So what's the sum of 90 and 38? Just 1 second, I need to get my
28.
calculator, all right?
128.
120. 128.
All right, just now, let me just get my calculator, please. Okay, we got the calculator. Sorry about that. Back to this. So you all calculated it for me, right? It turned out to be what? 120.
120.
Right, right. So I'm going to put it in here. Can anybody kind of see what I'm getting at though before I'm doing it? This is 128. Right, I put it there. So isn't this angle, which I just drew in yellow, plus this 128-degree angle supposed to give you 180 based on what we just saw?
Yes, sir.
Yes, sir.
Right. So that means, in other words, that means this 38, well, this whole 128, add this 38, add this little piece what missing, should give us 180 degrees because both of these angles must give us 180. Using that knowledge, we could easily figure out the missing portion in this little corner. There's a reason why I'm going to want to find this little piece. You will see it very soon. So how can anyone could figure out what this missing piece is? Let me write it down. Let me write it here. So let's first figure out the size of the big angle. This big angle is going to be 180 take away 128. Remember, this angle
52.
and this, which is 52, you got 52 degrees. So if this whole angle is 52 and this little portion is 38, how do we find the remainder?
Minus
Yeah,
38
take
from
out
52.
From 52.
52 take away 38 is what? You'll get
13.
14.
14 degrees.
14 degrees, okay? So now I'm going to erase some lines only because I need to clean up the diagram, okay? So I'm removing these lines now. The line we just figured out is this line here. They didn't ask for it, but we needed it. 14 degrees. Can anyone look at this now and tell me if we could figure out this angle on top here called h by h?
Yes, sir.
Yes, sir. Yes, sir.
How do we find h now, given this 14 degrees?
38 plus
So I'll take it
14
from
and
here.
180 minus the 38 plus 14.
Very good. I'm writing that here. So somebody work it by the time, please. Let me write it down here for students. 180 take away the sum of 38 plus 14. In the event that students don't know why we're doing this, I will tell you. This is a triangle, right? A triangle has 180 degrees in total. So that means if you add up these two angles underneath and take it away from 180, you will get the missing angle. What is this missing? What is this angle now?
128 degrees.
128?
128.
Very good. Now, it all is like solving a puzzle, eh? That's why this is I actually didn't hate this topic because it was like solving a puzzle. Because watch how easy we're going to find this missing angle down here now, eh? You're gonna be so shocked. I'm going to draw this cyclic quadrilateral here for you. Look at this. Right, so we draw in this. Before I draw it, let me just put in, remember we fill in the answers we get. So this answer here was what? What was it, 128? I'm going to write it in 128. Right, I'm writing it in because it is going to be useful to us now. Now, allow me to draw on the diagram using a tick point, probably a blue. So I'm going to draw here, going up here, coming here, and here. Okay, what shape again is this?
Cyclic quadrilateral.
Like the quadrilateral.
And what do we know about the opposite angles in a cyclic quadrilateral?
It's
Supplementary.
They are
the same.
So wouldn't that mean that this angle down here, which we need to find, must add up with 128 to give what? What these two angles must give?
180.
180. So could we use that knowledge now to figure out this missing angle of 128 degrees?
Yep.
Yes, sir.
Yes,
Yes,
sir.
What do we type? What do I write here? That will be
180 degrees minus 128 degrees, and you'll get 52 degrees.
52 degrees. Okay, so that means that this angle down here, so we found two of the angles already that we needed to find for this question. So this missing angle down here is 52 degrees. All right, so far so good. By the way, we had figured out an angle earlier, right? And I didn't include it in the diagram, but I want to include it in the diagram now, right? So we had figured out something earlier, that this angle here, I don't know if you all remember, but we had actually figured that one out when we did let's just leave it for now then, right? In case you all can remember it. That was this 52 we have up here. You remember how we got this 52? If you can't remember, you might have to check back the recording. But that 52 was this angle here, right? I didn't get to include it. Mm-hmm.
So it's a triangle, so it would be 90 plus 52 plus 38. And 180 minus the sum.
Okay, yeah, right? So I just wanted to include it now because remember we included all the angles we found. It's 52. I put it, right? I just want to put it in for the sake of completion. Right? That was one of the angles we had found earlier that I forgot to include in the diagram. So we have one more angle missing. That's this angle in the corner down here. And it's not a difficult angle to find. It's really an easy angle to find. Because it have two ways, I believe, we could find that angle. It have two ways we could find that angle. One of the ways,
So angle K?
Angle J.
Oh, G, okay.
J. This little thing here, I'm gonna use a ticker point. This little tiny tiny thing here that I shaded, right? That little tiny thing was what we need to find. It brings us to this circle theorem that I want to share with you. This one on the left. Angles in the same segment. So what I tend to, when I'm doing this topic, I just call this the butterfly rule because it looks like a butterfly wings. Okay, that's how I kind of describe it to my students. So in this theorem, we have a chord, which is just a line that separates the circle into two portions. And if we draw lines, like in this pattern, basically, touching the circumference back to the origins of this chord, these angles are going to be equal. The angles that touches the circumference are going to be equal. So these two are going to be equal, and these two on the bottom here are going to also be equal. Okay, so this is one of the rules that you may have remembered. Using that knowledge, can we see that shape here? That butterfly shape. I just call it the butterfly rule.
Yes, sir. Yes, sir.
Let's draw that
The
out.
angle 52.
You're seeing it now? And for those who didn't see it, that's the same butterfly there. There was a reason why I put back the 52 that we found there. Because if we could figure out this angle, it's going to be the same as this angle because of that rule we just saw. Do you all agree with that? Let's look at the rule again. The angles at the tips of the wings will be the same. You're seeing that, right? So the angles at the tips of the wings are going to be the same. So here's the tip of one of the wings, here's the tip of one of the wings. So let me draw back this butterfly in case you're not seeing it. I just call it the butterfly rule. The angles at the tips of the wings here are going to be the same. Is there any way, given the information on this screen, we could figure out the tip of this wing here?
Yes, sir.
How can we find that portion?
I mean, we already have the 52, so we just minus the 48 from that to make it 48.
So if that angle is 14, right? So that is 52. That's the 52 we had found up here. So that 52 take away 38 is equal to 14 degrees. And that 14 degrees, if that is 14 degrees here, it is going to also be 14 degrees here. And that is the last angle. The reason why I showed you that one with the butterfly wing is because I wanted you to be able to see it. Now there's another way we could have found that angle. Let's see if we could figure out the next method to find that angle. It's very easy. What type of triangle? Now, a student, you might, as a student, might use different methods to find the same type of angles. There's not one particular answer. What type of triangle is this that we are seeing here?
Isosceles.
These lines, what these lines means here?
So both are equal.
Right, so they are equal. So this is an isosceles
Both
triangle.
equal.
Okay. Now, if this angle was 52 degrees, wouldn't that have automatically made this angle 52 degrees as well? Because it's an isosceles? In case you cannot remember how I found that 52 earlier.
Yes, sir.
So you're supposed to be able to know this is 52 degrees based on that. Now another thing too. If these two angles are 52 degrees, can we find this angle here?
Yes, sir.
What would that angle be? Can anyone tell me?
The sum of 52 minus from 180.
Right, and what is that? 180 take away 104. Right? What do you all got?
76 degrees.
Right. Can anyone see where I'm going with this?
Yes, sir. Yes, sir.
Let's look at how we could go with this. Remember, this, I'll use my pointer for this, okay? So let me put in that angle here. What did we get for that angle? 70, what? 76? That is this angle here, right? This big angle here. We say this is 76 degrees, and I'll just draw it up, right? That's 76 degrees. If we know this is 76 degrees, I'm using a big pointer, this is 76 degrees. And look at this here. Isn't this 90 degrees till this line? 90 degrees?
Yes, sir.
Yes, sir.
So if this is 76 and this is 90, the whole from here now to here is 90. So let me draw it in like this for you to see. This whole piece here now is 90, right? This whole thing is 90, right? So what is 90 take away 76?
14.
So that's another way we could have found that 14 degrees there. You all saw it now? It's a little angle. It's a little angle, right? So let me remove it. So if I remove all of this now, you might be able to see it better using your red line. This is 90 degrees, and this angle here we had just figured out was, I think, 76 or something, right? I can't remember. So if you take away the 90 from the 76, you're gonna get this little portion that remains, which was 14. Right? So that's another way you could have tackled this. Right, so that actually is the end of the circle theorem question. And we have to move on for the interest of time, because we still have 2 questions to do on the paper. No, we're on 9, so we're not moving that bad. Right, so I hope after this, I know a lot of you on the YouTube live, even here, who are not answering, you might be confused. But you need to be very attentive when you're looking at a circle theorem question, and you need to always write down. Once you find a missing angle, it's not insignificant. Once you make out an angle, write it down on your diagram. If you forget an angle, you'll throw yourself off. And you see this little thing what I have here? The circle theorems document. Learn the general theorems, because you notice everything we did there was based off these same principles. It wasn't too much different from what we saw here, okay? It's
You can post that in a Google Classroom.
Yes, I'll post this in the Google Classroom for you after, right? So you could have that, right? So you all could use that information and practice as much circle theorems as you can. Go forth and conquer with those circle theorems, right? I wish if I had enough time to do many of these examples, but we don't. We are very limited with time. But I just want to show you that it's possible to do them. Think about it like solving a puzzle, right? So we were able to find these triangles. So I will be quickly moving on to the bearings question now, right? So we're going to analyze this bearings question, which is going to take up some time because it does require some work. Okay, so the bearings question.
Where's angle message, sir?
Sorry?
No.
No problem. All right. So let's look at this bearing question here now, because students tend to hate bearings and we need to talk about bearings. All right, so let's read. Right, we're shifting our gears to bearings now. From a port L, ship R is 250 kilometers on a bearing of 0.065 degrees. So from the port L, this ship R is on a 250 kilometers away from the port on a bearing of how much degrees? 65 degrees. So I'm going to quickly write that in here. I already draw that crooked line there, but I'm putting in my 65 inside. Okay, if I don't put the degrees symbol, guys, forgive me, because I don't have the space to make it look too neat. Right, so I just put in the numbers, the magnitude of the value there. So 65. That is what that means. Also, just to recap something that you may haven't forgotten, when we deal with bearings, right, we have a north line. And what direction do you read bearing angles? Do you know?
Clockwise direction.
In a clockwise direction. So that is why it is always start from the north line to here. So this is a clockwise direction. It is 65 degrees. Bearings are always measured clockwise from north. In case you didn't know that, you know it now. Right? So that's the first thing about bearings with that particular point. Moving on, let's read the rest. Ship T is 180 kilometers from L. That's down here, okay? Quite down here in the diagram, all the way down here. So ship T is 180 kilometers from L on a bearing of 148 degrees. So what does that mean? That means, that means that from the port L, if we continue here to here now, from this direction, we always start from the north, we always go clockwise. They told us that ship T is 180 kilometers, that is what we could see here, on a bearing of 148 degrees. So this whole angle is going to be 148 degrees. This is why I want your help. If we know the whole angle is 148 and this angle is 65, can we figure out the missing piece in here?
Yes.
Yeah,
Yes,
take
sir.
away the
Right,
65 from the 40.
right. And what would that give us? Can someone tell me that quickly?
83 degrees.
Very good. So I am going to remove this just for the interest of space and neatness. And because I know the question, this is very important for us here, 83 degrees. Okay? This information is now illustrated in the diagram below. I included the angles. They want you to complete the diagram above by inserting the value of RLT. Did we just do that? Yes, we did. We actually just did that without even thinking about it. RLT going down here, right? So that was this missing angle in the middle we just found out there. So that was a mark to do this. What I just now did by reading the question, you got a mark for that. Okay? Everybody okay so far? Now, this is where the question veers off into trigonometry. Okay? Calculate RT, that is the distance between the two ships. RT is the distance between the two ships here. RT. Okay? This is where you need to know what is sine and cosine rule. This is where we actually arrive now at this question. So let me, you do not need to memorize the formulas for sine and cosine rule because they are provided for you in your formula sheet. Before we could go into sine and cosine rule, I want to, in this question, I want to bring it to your attention in this diagram I am preparing, right? So let's not take too long with it. Let's try to see if we could figure out sine and cosine rule. How much of you here, by switching on your mic, have problems in figuring out when to use sine and when to use the cosine rule?
Me.
Right, so I'm going to try to clarify that, and I'm going to post a video if in case I'm not successful at clarifying it today. In this session, I have a useful YouTube video I always refer to keep myself refreshed on this topic, and I'm going to share it on the course after. Okay, so you have that to look forward to as well. So I'm going to use a very similar technique to that video because it's very useful. So let's look at this now. Eh? Is this a right angle triangle? No, right? It's not. This is not a right angle triangle. These are not right angles. It might look like a right angle slightly, but it's not. You do not, you use this method here of these rules, the sine rule and cosine rules, when it's not a right angle triangle. That's the first thing. You use them to, well, because this is not a right angle triangle, we can use this rule to do, these two rules to do one of two things. You could use it to find a missing side or find a missing angle. That is why we use the sine rule and the cosine rule, to find a missing side or angle of a non-right angle triangle. When you're doing these questions, what you will do is, I want you to do, is the angle, let's say you are trying to find a missing angle. Always label the thing you are looking for A. Always label the thing you're looking for as A. If you are looking for a missing angle, now the notation is, the convention is when we write these things, we label the angles as capital letters. So this could be A, B, and C. Okay? Capital letters are for angles, common letters are for sides. So if this angle is A, the side opposite that angle is going to be called common A. I'll use a different color. Common A. If this is B, the side opposite B is going to be called common B. And if this down here is C, the side opposite this, we're going to call it small c, right? Small c or common c. How do we know now? Now that we have an understanding of how the triangle looks like, we need to figure out when to use sine rule and cosine rule. I will tell you sine rule first. To find sine, okay, the only time you could use sine rule. Now I have a document here. So let me write down what sine rule is quickly. Sine rule is either A on sine of A is equal to B on sine of B, basically. It's a ratio. Now these formulas are going to be available to you in your formula sheet in front of your booklet. Now, as a rule of thumb, you only, well, let me show you how these questions tend to come basically before I explain it, right? So a question will come like this. They will always, you will always have to find something. So they will give you, let's say they give you this angle is 30 degrees. They say this is 10 meters. And let's say they ask you to find this missing angle. Not 10, let me put this 10 meters here. You'll see it. Let's say this is 10 meters here. Let's say this is 25 degrees and this is a missing side. The way we know which rule to use is by looking at something called matching pairs. This is a matching pair because we know the side and we know the angle up here. Once you know both of them, it's called a matching pair. In this side now, we have the angle, but we don't have the side. So anytime you encounter a question and you find a perfect matching pair, you know to use the sine rule, like how we have 30 degrees and 10 meters. Once you identify a matching pair, you use the sine rule. In the event that you do not have a matching pair, you have to use the cosine rule. That is how to tell when to use the sine rule, when to use the cosine rule. In this question, if I were trying to find x, I will use the sine rule because I have a matching pair. Let me show you what a non-matching pair looks like by looking at our question. Remember that we must have the angle and a corresponding side. We must have this correspondence. If we do not have this, we cannot use the sine rule. Let's look at this triangle now. We have one angle alone in this triangle. This here is the corresponding side. We do not have a matching pair. We need both. We need a complete matching pair before we could use the sine rule. Because we do not have it in this question, we cannot use the sine rule. That is how to tell when you're going to use the cosine rule. So that means for this question, I'm going to use the cosine rule. If you think you're picking up slightly on what I'm saying, and you want a further investigation into that concept, wait till after class, and I'm going to post a video, not a long video, going into much more detail and providing much more examples on that concept. But it's an easy concept to understand. If you are given a matching pair, like here, whoops, how we have the 30 and the 10, then we could use the sine rule. What you don't see a matching set, we cannot use the sine rule. Okay? That is how to tell when we can use sine rule and when we can use the cosine rule. So with that being said, I'm going to do the cosine rule. And your formula sheet is going to give you your cosine rule. It's going to give you the cosine rule. So I'm going to write down the cosine rule here firstly, and then we'll deal with the diagram. So this is your rule that will be in your formula sheet. A squared is equal to b squared plus c squared minus 2bc cos a, and that's the cosine rule. It looks like a mouthful. What did I mention earlier? Always label the thing you're looking for if it's a missing side. So we are trying to find this missing side. Always label the thing you're looking for as A. So this will be common A. Okay? That's the thing we're looking for. I'm going to call it A. That would mean the corresponding angle to it, that is the only angle that we know, is going to be capital A. The other two sides here, you could label them B and C in any order you want. I just put in B and C. It doesn't really matter. That is how we label the triangle. The thing you're trying to find is always given preference in letters. Now, this is not, you wouldn't find this anywhere. So this is my personal techniques I'm using here. It always works well. So the thing you're looking for, always name it A. So now we know what A is. That's our unknown. We know what C is. We know capital A. We know B. Now, this is a common C up here. Let me fix that. This C looking too big. Remember, these are common letters on the outside. Capital letters are for angles. We know we have a number for all of these variables here now. It's just a plug in and solve. That is how easy it is. The reason why I put my unknown as A is that this is already the subject of my equation. So when I solve everything, I'm going to find my answer one time. I have no rearranging to do. So let us do it. What is A? A is what we're trying to find. So I'm putting it as A squared. In my diagram, what did I label as B? 180. I'm putting it as 180 squared plus C squared. What is C? Could you see that C is 250?
Yes, sir.
C is 250 squared right? So you can see it there, right? C is 250. And make sure and don't forget your squares there. I'm just filling out the information now. Minus 2BC. We already saw what B and C was. Okay, we could just look at it right here. B is 180 and C is 250. So 2BC. So B is 180. C is 250. Cosine of A. And what was angle A? 83 degrees. Cosine of 83. Right. Can you see that all of this on the right side has no variables? This is just going to work out to be a number. You could plug in this whole thing into your calculator if you are confident, and you will get a solution. All right, so if you plug in this whole thing into your calculator, can someone simplify this for me and tell me what you're getting? It should get something around a decimal number over 8,000.
I get 8,000. Like 3,931.7590.
Oh yeah, it's over 80,000, sorry. Yes. So it's 83,000, right? 83,301. Wait, sorry, can just follow back.
931.
931. Point something.
7590.
All right, let's keep it at 759 because it doesn't matter the decimal point, how big the number is already. Right? And that give us A squared? How do we find for A? If we know what is A squared, how do we get A?
Square root of.
Find the square.
We just need to find the square root of this number. Right. So what is the square root of this big number we just now have here? The square root of that. What would that give us?
289.70.
289. Oops, why did I put that point there? 289.71 kilometers. So that is the distance here now. Okay, that's the distance. 289.7. That is how we find it. I'm going to write it here. 289.71. I think somebody said kilometers. We just need to know when to use the cosine rule and use the cosine rule.
Excuse me, sir. So, you could go one decimal place or two, it doesn't matter.
It doesn't matter to put. I could approximate this thing. I would actually approximate my answer as 290 because look at the values here. They are, if you're looking at significant figures, all of these numbers here, the 180 and the 250 are given to two significant figures. So I would have just approximated to 190. But because in the next part of this question, we need to use this, I will keep it as detailed as possible, as much points as possible, so that we wouldn't get approximation errors when we use this value in the next part of the question. Yes, there's a next part of the question. If you put only one decimal place, don't worry. If you put two, that's nothing, right? That they wouldn't penalize you for that. So let's look at part 2. Determine the bearing of T from R. Now this one could take a little time. This is the longest question to do on the paper, in my opinion. The next question we do in the vectors and matrices one, it wouldn't take us that long. This one is going to take up some time. So let's do it. Calculate, determine the bearing of T from R. How do we interpret that? What is T from R? That means you're starting, yes. So I was going to say something.
Sir, I was going to say you're going to start from T. From R, sorry. R.
Very good. Look at the word in from R. So you're going to start from R and then go to T. That's how you interpret this. If you say determine the bearing of T from R, you're starting from R and then you're going to T. So let's look at where that would be in this diagram. R is up here and T is down here. So you want to find the bearing of R from T. So let me draw that. Now, you see how they draw this north line here? I tend to like to continue it a little lower down, because lines are always our friends, okay? So I'm going to make my north line. You mightn't be accustomed to this, but I'm going to bring it down a little longer. You will see why I'm doing it soon. This is my north. What do they want us to find? They want us to find the bearing, so that would be a clockwise value. So let me draw this not a little higher. That's good. We have to find this angle here. I'm drawing it a little big because I know I will need to do some work in this space soon. This is the angle we want to find here.
Sir, sir.
Mm-hmm.
Sir, sorry for this. Somebody in the chat said they're having trouble plugging in the previous question in their calculator.
If you're having if you're having trouble putting this whole thing into your calculator, do them in parts. Okay, so if I was doing this in a normal sharp calculator, I would figure out what is 180 squared add 250 squared first, and then I would figure out this portion. 2 multiplied by 180 multiplied by 250 multiplied by cosine of 380 of 83. And then I would take away those two things. If you can't plug, because brackets is the key, make sure when you're doing it, you put everything in a bracket. If you're inputting this into your calculator, make sure you use your brackets properly. You see how I have some brackets here? That is what might be throwing you off. But this answer is correct. I believe so, because I had gotten this answer when I did the question. So if you know you're getting a little difficulty plugging it in, try using brackets firstly, and if not, try working it in parts, and you will eventually get an answer that is close to this answer, approximately very close to it. All right, that's the advice I will give for a student who cannot plug in the whole thing into their calculators. All right, so right, I just want to talk a little bit about this bearing question, because this question here, this portion here is going to be a little difficult for students to grasp. Let's look at how to do it though. So I know this question tends to be hard. This portion is going to be, I might lose some of you for this, but let's look at how to do it. This angle here is what we need to find in this question. This angle represents the bearing of T from R. How are we going to find this angle with this information that we have? That is the question. Now, there are a few things here that we know of already.
Oh yes, sir. Sir, you know, say it's.
Sorry.
Say the bearing is. Oh no, never.
Yeah, this here, this is what I drew here, is the question. This is the bearing of T from R. The bearing is the angle. Okay, so this angle inside here, the space there, this angle between the north line and this line, this angle here, this is a what type of angle is greater than 180 degrees? This is a what type of angle? A reflex.
Reflex, yeah.
Right, so we need to calculate the size of this angle, and that is what's going to throw off a lot of students. So let's see how to do it. Now I want you all to focus. We're gonna try to finish this question. Can't take too long on it, because I still want to do the vectors and the matrices with you all today. So let's try to see if we could get all the content at least recorded. So what we're going to do here is I am going to use some important properties. These two north lines are very parallel to each other. Can you all agree with that? They are parallel to each other. What do we know about parallel lines with a transverse? Did we spend a lot of time on that just now? Don't you realize, don't you realize that this north line, this is a transverse? Can you all see it? These lines are parallel to each other. So if this is the case, if that is the case, wouldn't this angle here be 65 degrees?
Yes, yes, sir. Yeah.
Very good. Also, this portion of the angle that we need to find, how many degrees is that?
Sir, no, 180. That's right. Sir, that is at the 180 plus the 65, right? And that would have
No. Actually, no, because if we add the 180 and the 65, this is going to push to here. And we actually only want to stop at the green arrow, where the green arrow ends. So you're seeing the dilemma we're in right now, right? You're seeing as an actual physical problem. But what if we knew this angle here? We're just drawing. If we had known this angle I just drew, that I'm going to call A, capital A actually, and if I take that away from 65, I'm going to get the missing piece. You all see that? And then if I add that to 180, am I not going to get my actual bearing?
Yes, sir.
That is what we're going to do. So what we're going to do now is we are going to use the sine rule to find angle A. Let me repeat that. We're going to use the sine rule to find angle A. So let me sketch this thing for you now. So let me sketch the triangle, and the best way I could sketch it. So this is the triangle without all the lines, right? Oops, what am I doing? So let me try to draw it like this. So it's so coming along so, and it's like that, right? That's the triangle. We know this is 83 degrees. That is what they gave us, 83 degrees. We know this is 250 kilometers. We know down here is 180 kilometers. And we know this side was 289.71. That's what we just got, 289.71 kilometers. What was the condition we need in order to use the sine rule?
Sir.
Remember I mentioned it earlier.
Needed to be mapped.
Matching pair.
Don't we have a matching pair now?
Yes, sir.
We do. And this is the angle we're trying to find, right? So this is A. So we wouldn't need all the information on this tape, on this. We just need some to get that angle A. And to be honest with you, we don't need the 250 because it's not relevant for this. What we're going to do is, because we have this matching pair, we will use this information and this information to find angle A now, using the sine rule. You must have a matching pair to use the sine rule. Let's look at how to use the sine rule. Before we use the sine rule, let's label our stuff. If the angle is A, what would wouldn't the side be common A based on my convention?
Yes.
Because right?
Yes,
And then what letter comes after A? B, right? So I will call this angle B here, and this side will be common B. We don't really need to worry about this angle on this side, because the question has nothing to do with that. You just need 3 pieces of information, which we have, the 180, the 289.71, and the 83, to find the missing thing. Because the sine rule, I'm going to do it right underneath it one time. Right? The sine rule is basically, let me remember it off head. No, I can't remember that offhand. How do I the formula sheet?
Sine A.
Capital A on sine. Okay, I'll go with common first. I think I will go with the common. So the sine, the rule is common A on sine of a capital A would be equal to common B over sine of capital B. I believe this is what you have in your formula sheet. Right? Now, don't we know what A, B, all these A's and B's? Didn't we label everything already? It's just a plug-in into our equation. So what is common A? Common A is 180, as we can see on the top of the screen. So that will be 180 over sine of A. A is what we're trying to find. So I'll put it as sine of A equals to B over sine of B. B is 83. Small b is 289.71. So let me put in that now. 289.71 over the sine of B. And we know the sine, we know capital B, that's 83 degrees. So this will be the sine of 83 degrees. So isn't the only variable here is A? So what can we do to solve this? We could cross multiply. We're gonna cross multiply this, okay? Now I shouldn't have even write it because I'm running out of space. So let me try to cross multiply it as linear as possible. Yeah. So let's just start with this numerator.
Sir, I have a question.
Yes.
Why didn't you write sine A over 180 instead of 180 over sine A?
Because sine is always of an angle. Remember, sine is always of an angle. 180 is not an angle, it is a side. Okay? Sine, and we always
Yes,
label.
sir, I get that. I'm asking why you didn't write it. Why you didn't put sine A at the top and 180 at the bottom?
Oh, so you're asking why I didn't put sine A over A like that?
Yes, sir.
Is that right? That's actually that's not a problem because there are different ways you could interpret the formula. This same formula would give you the same answer as if you use that method. So you could always try that as well. You could have put sine A over A equal to sine B over B as well, and you would get the same answer as what I am doing here. I chose this one because I can't check the past paper, the formula in your past paper booklet right now, but I think this is the one that's in your past paper booklet. But both of these things are just ratios, okay? And it doesn't matter really which one you choose because they are still the same thing. In essence, the same numbers. So they are both the same thing, really. So it doesn't matter really which one you choose. You will get the same answer using either ways of writing the sine rule. Is that clear? It doesn't really matter. I just chose this method because I think that this is the one in your formula sheet, but it could be this one. I can't remember offhand. I really can't remember which one is in the formula sheet, which method, but it doesn't matter. Both of them are equally correct. And there's when you look at the video, if you look at the video I post, they will explain this same question you're asking in detail based on if you're trying to find a side or an angle. All right, so if you want to find an angle, a missing angle, you should use the green formula. So what we're actually trying to do is find an angle. So I should have actually used the green formula, but because it's the same thing, it doesn't matter. You can still use this one. So the video will really help you with that, with a little more clarity on that question. But that's a good question, and it doesn't matter really which formula you could use there. So I'm going to just write this this equation, and I'm going to skip to the answer for the interest of time, okay? Because I think you all could solve this one if I write out the equation for you. So if we were going to cross multiply, you would have 180 being multiplied by sine of 83 being equal to 289.71 being multiplied by sine A. And what you want to do here is solve for A. So you need to first find for sine A. So what you're going to do, right? So what you're going to do, I'm going to write that 180 a little closer. What you could do here, for those who may have difficulty solving for A, you know, you have to get rid of this. You want to free up the A, so we're going to get rid of that first. So I'm going to just write it a little lower, right? I'm going to write over here based on this equation. So I'm going to erase this line. So what you're going to do, to get sine A on its own, you need to divide both sides of this equation by this to get rid of it. So you're going to end up with 180. You can plug in this into your calculator, sine 83 over 289.71. And that is going to give you sine A. That is going to give you sine of A, sine of the angle. And if you want to, I don't know if anybody did it, but if you did this, if you plug in this into your calculator, you should get 0.62 is equal to sine A. Okay? That is what you should get there. Anybody could check it, but you should get 0.62.
Yes, sir.
Right? Is equal to sine A. So if we know that, how do we find for A? We need to do what?
Sine inverse 0.62.
Right. We need to find the sine inverse. Sine inverse, which is sine to the power negative 1 of 0.62, is going to be equal to A. And that should work out an angle of about 38.31 degrees is equal to angle A. So this is the sine rule, guys. Right? So that was the cross multiplication we did. But we didn't finish the question. Eh? Remember, just taking that you all could do the calculation, we found A. What that does for us is we know what angle A is. We know what angle A is. Angle A is about 38 degrees. So now that we know what angle A is, which is 38 point something, what did we get? 38.3? 38.3 degrees. Can we find this missing portion now? We must
Yes,
take it.
sir.
Yes, sir.
What would it be? The missing portion is going to be 65, take away the angle we just found. What would that give us? What is
26.7.
26.7, right? Okay, so let me write that in. So I'm going to write it in with this thing here. So this angle, I'll use a different color. This angle here now is going to be 20 what? Sorry? Can you tell me?
26.7.
So now if we know this angle here is 26.7 degrees, remember the bearing is up to the end of the green arrow. We know this little corner now is 26 degrees. We know the big curve is 180. So what would be the bearing then? What would be the bearing? It would be the sum.
206.7.
206.7. It would just be the sum of 180 and 26. So that's the bearing. So the bearing, the total bearing, the bearing is going to be 180. Let me fix that. 180 add 26.7, 26.7, which is equal to 206.7 degrees. And this is the answer for the last part of the question. All of that working just to get that bearing. You see how much technique you needed to use in this particular question? If you know you're skilled with your mathematics, do these last few questions first, guys, before you go into tire yourself out with the first questions. That's the answer for this one. And that would have bring us to the end of yesterday's document that I am saving. Now, because we have half an hour, I want us to move on to the last thing. So I promise that this one wouldn't be that bad because we're going to do the 2013, the 2023 vectors and matrices question from the January exam, because this is the most recent one. This is the last one. I wanted to do this with you. So that was the end of the bearings question. I know it was a little bit of work. I know some of you may have gotten lost, but I'm going to put some resources for you to look at with circle theorems. Not circle theorem, sorry, with sine and cosine rule. Once you sharpen your sine and cosine rule, reattempt that question, and you will see how easy it's going to be. But it does require some technique, and it does require you to have a clear mind and an open mind. Let's look at the last question on the paper now. Okay, we finally had made it to question 10, and this is not that much, so we're gonna get this done. So they started us off with matrices, and they ended it off with vectors. So let's do this last question together. Right, so this is the question that came in January. Let's see if we could get it correct. The three matrices Q, R, and S are as follows. We have three matrices here, and for me, it's very shocking they give you all such a weird matrix to it, because normally there's only really focus on square matrix like this. But they really don't want you to use this matrix in any calculation. They want you to use this matrix.
Sir,
Yes.
sorry to stop you there. I have a question regarding the question that you just did. Should I wait after you've
No, you can
completed
ask,
this?
but you ask it one time as it's
All right, so
fresh.
I have a theory, right?
Mm-hmm.
Using the question that we just did. So you're using quadrants, right? You're using the north, east, south, and west. Each quadrant equating to 90 degrees. You give north south to be 180, and you had worked out earlier that southwest is 65.
Just one second. That would have been southwest. Yes, not entirely southwest, sir, but this would be like
it's not
southwest.
entirely. So
Yes.
part of it is
65 degrees.
Is 65. If you should take the 65 from the 90, it will equate to the 25.
That is up here, right? That would be this portion up here,
Yes.
right?
So if you add the 25 to the remaining that are not necessarily add but take away, wouldn't it also give you the value of, well, not exactly 206 but 205?
Just now,
Or
let me
so?
see. So that's the 25 over here that we're looking at, right? On the sun, we're saying up to the 25. Let me see if I could sketch that in here. Let's see. So I'm going to draw this line across,
and
this is the 25 there, okay?
Yes.
Right?
So where
Right.
you have the 180 on that side, the other side is also going to be the entire
Side is 180.
northwest, east, south would also be 180. And all of that will add up to 180. Because you said doing bearings is supposed to equate to 360, correct?
Well, the full circle would be 360. So not
360.
necessarily bearings, but generally properties of a circle would give you the 360 degrees.
360. And if you have already worked out the 65, once you take away the 65 from the 90, shouldn't it already give you the 25? Or
Right.
the 26.7 that you just
Yes.
worked out?
So you wanted us to use, but the problem with that is that degrees difference would make a difference here. If this question didn't, if the values, right, weren't exactly what we got here and was different, that difference might have been bigger. Right now the difference is a little small, so it's a little suspicious, right? It's kind of coincidental. But if these numbers were not the same, that difference might have been a little more significant. So because the question doesn't, the question would want you to follow this particular method, because we need to find exactly this angle, okay? Because because 25 here is similar, we can't really make that leap,
assumption,
right? Yeah, we cannot make that assumption in this particular question. The fact that the numbers are that little difference of degrees there is very, very, very important in navigation. All right, so it's very similar. Yeah, it's similar.
I was looking at it as being one of the quadrant being 90 each. So you have northeast 90, southeast. Yes.
I understand. No problem. But I'm glad you cleared up that. But I would not use that technique and use this one, because that was just a coincidence. The values were similar, but it wouldn't work if it was probably different values.
All right, thank you.
No problem. That's the point is for to ask questions, right? So I'm leaving this document. Let's go on see how much of this we could do now. All right, so we're gonna finish this one. We're gonna finish this one. Let's do it. So the first question is, let's go into the question. Explain why the product of Q and S is not possible. Q and S. This is a 1-mark question, meaning that you don't need to put too much thought into it. This is basic stuff you need to know regarding to the multiplication of matrices. Do you know that there's a test of compatibility for multiplication of matrices? Do you know that there's a test of compatibility? Yes, you have to switch on your mic, so guys. Test of compatibility. Do you know that? Let me show you the test of compatibility. I may be making it sound scary, but it is actually really easy. We need to write out something called the order of each matrix. Order is simply rows times, or R times C, rows times column. That is the order of a matrix. This matrix has 2 rows, as you can see here, and 2 columns. So the order of matrix Q is a 2 by 2 matrix. Matrix S, there are 3 rows, and how much columns are we seeing? 2 columns. So this is a 3, matrix S now is a 3 by 2 matrix. The test for compatibility is as simple as this. You write down your orders and you compare these numbers. You write down your order just like this. In first number, Q, you see Q is the first letter, you write Q first. S is the second letter, you write S after. and you look at these two numbers, these numbers must be the same so that you can multiply the two matrices together. These numbers, again, let me repeat, these two numbers must be the same so that you can multiply the matrices together. So the reason, because these numbers are not the same, you cannot multiply them. Have anyone ever seen something like this before? No one? Hello? No one?
Yes, sir.
Yes, sir.
Right.
Yes,
And
sir.
that's the answer for part 1. And for part 2 now, state the order of the matrix product. Order of the matrix. Do you know that the order of the matrix from a multiplication? Now look at this. They want the order of the matrix product for S and R. So we're going to do the same thing for S and R now. So what is the order of S? We have to write the order of S first. So we're looking at the product of S and R. So S, the order is a 3 by 2 matrix, and R is another 2 by 2 matrix. So looking at the inner numbers, we can see now they are the same. So S can be multiplied with R. This will be possible. And these two numbers on the outside is what gives you the order of the product matrix. The product matrix is your answer. So your answer will be a 3 by 2 matrix. So that is the order of the product matrix if you multiply S by R. Okay, S and R. So the product will be a 3 by 2 matrix, and that is the end of that part of the question. These are 1 mark each, so they expect you to know this. And I think you all know this already, okay? Do you all know that multiplication of matrices are not commutative?
Yes, sir.
Yes, sir.
That means, what that means is, if you have matrix A and a matrix B, and you multiply them together, and you get a matrix for your answer here, that will not be, this answer you get is not the same as if you had multiplied B by A. If you go to multiply B by A now, the same B and the same A, you're going to get a completely different matrix. So matrix multiplication is not commutative. That is what that means. So they want us to work out the product of Q times R. Okay, so let's see if we could do that. So we're going to write down what Q is and R is. Right, so we'll get through this. This one easy. So let's do Q times R. You all remember how to multiply matrices? Q times R. You all remember, right?
Yes, sir.
Let's do it together. So matrix Q is 2, -1, 4, 3. Let me write that down here. 2, -1, 4, 3. That's Q. And we're multiplying it by R. Let's look at how to multiply matrices. 1, 6, -5, 4. 1, 6, -5, 4. So multiplying matrices is a technique that some students struggle a little bit with, but it is not a hard thing. You need to remember a concept called rows by columns. You're always going to multiply rows by columns. So what I do is I try to think about it like this. I multiply my first row by my first column first. Then I multiply that same first row by my second column. Then I move on to my bottom row by the first column again. And then the bottom row by the second column. That is the technique that's the method I go with. So let's see if we can make sense of what I said there. When you multiply a matrix, let's look at the first row and the first column. That's what we're looking at first. What you do there, and I'll write it below, you have to multiply the first element in the row by the first element in the column. That's the 2 and the 1. And you will add that to the product of the second element in the row by the second element in the column. Is that sounding familiar to some of you? That's how we do matrix multiplication. Row by column method. The first element of the row by the first element of the column. Then the second element of the row by the second element of the column. So let's see if we could if we could write it down now. So the first element of the row is 2. Multiply it by the first element of the column, there is 1. And you must add it to the product of the second element in the row, which is this element here, -1, being multiplied by the second element in the column, which is -5. There's no other way to do this beside that. You have to do this multiplication like that. So we multiply the first row by the first column. By doing this, we had did that multiplication. Now we're moving on. Now what we have to do is do the same thing now, but we're multiplying the first row now by the second column. The exact same thing, we're going to do it again. So we have to multiply the first row now by the second column using the same method. So that would be the first element of the row is 2, multiplied by the first element of the column, which is 6, and you must add that to the second element of the row, which is -1, multiplied by the second element of the column, which is 4. Same technique. Now that we've done that, we finish multiplying this top row by both columns. We go on now to the bottom row and multiply it by the first column. And that answer will be written here. And when we multiply it by the second column, that will go here. Okay, so let's do it. We're multiplying now by the first column. So again, first element of the row is 4, multiplying by the first element in the column, which is 1. And you are adding that to the second element in the row, which is 3, multiplied by the second element in the column, which is -5. That is it. That's the technique of row multiplication. And the last thing now, we deal with the last column. What we're going to do, the same thing again. The first element in the row is what? What is the first element in the row? 4 times the first element in the column, which is 6. Add the second element in the row now. The row is the horizontal ones, columns are vertical. So the second element in the row is 3. Multiplied by the second element in the column, which is 4. Once you do this and you lay it out like this, these two numbers must be the same. These numbers must be the same. Look at the pattern. These numbers must always be the same. In order to finish this question, we just need to solve each one of these things here. So this is what you would have to help me with. What is 2 times 1? Let's do it. 2 times 1 is?
2.
2. Let me use a different color, right? So you'll help me with it. We add in that, what is -1 times -5?
5.
5. Let's move on to the next one. What is 2 times 6? We go in here now. 2 times 6. 12. Add, what is -4 times 4? -4. So I'm going to just change it to -4 here. What is 4 times 1?
4.
And what is 3 times -5?
-15.
What is 4 times 6?
24.
And what is 3 times 4?
12.
Now let's continue simplifying. We'll write it in down here. What is 2 plus 5?
7.
7. What is 12 take away 4?
8.
4 take away 15.
-11.
Minus 11. 12, 13, 14, 15. It'll be minus 11, right? And 24 add 12 is?
36.
36. And that is your answer. That is how you do matrix multiplication. I'm sorry, I didn't get to teach matrices to you all as a whole topic, right? That is the answer for this question. And we have one more matrices thing to do before we finish with the matrices portion of the question. And that is this here. This is an algebra type question, but it is very easy. Given that A is equal to this matrix now, determine the value of X which is this x here, when we see in these two weird lines of A equals 15. What is this symbol asking us to do here? What's the name of that?
Determinant.
The determinant, right? This is the modular sign, but for this topic we call it the determinant. So this is what we're really going to do here is, do you all know what is a non-singular matrix?
Yes, sir. When it equals to 0.
No,
Yes,
that's a
sir.
singular matrix is when it equals to
When it
0.
doesn't equal 0.
So this matrix, because the determinant is not 0, this is a non-singular matrix. Okay? So if they ask you to find for x and they say when it's a singular matrix, you are going to use your determinant as 0. If it's because it's 5, we can know this is a non-singular matrix. That's how they tend to trick you up. If they ask singular matrix, the hint is they will just say singular matrix and you need to figure out the determinant is 0 on your own. But because they give you the determinant as 5, you don't need to worry. Does anyone know how to find determinant? Let's look at this. If I have this matrix A, which is equal to A, B, C, D. How do we get the determinant from that?
AD minus
AD minus BC.
Very good. So that is it, AD minus BC. So we're just doing the same thing. We're doing the exact same thing now. So AD minus BC. So because I told us that the determinant is 5, I could put 5. I don't think you always see that color good. You will put 5 because we know the determinant. 5 will be equal to, I'm going to put it on this side here, right under the formula. 5 will be equal to, what is A? What would be A?
4.
Right? What would be D?
X.
Minus, what is B?
Negative 1.
Negative 1. And what is C?
Negative 7.
Negative 7.
Now we just need to solve for X. So let's neaten that bracket. I put in Mac 5 equals 4x. Let's solve what's inside the bracket first because of BODMAS. What is negative 1 times 7?
7.
7. Okay? So inside the bracket, it works out to 7. So we just taken away 7. So now I don't even need the brackets anymore. Okay, so this is 5 is equal to 4x take away 7. Right, so let's see what's going on here. Right, just now, did I make a mistake anyway with this question? I'm feeling like something is not where it should be. Take a look at this and tell me, guys, is everything looking smooth in this question here so far?
Yes, sir.
Yes, sir.
Yes, sir.
All right, you're sure on thing, all right? Let's just double make sure everything is running smooth here. All right, so right, 4x, all right, minus 7. Yes, everything is running good. Just want to make sure. Right, so 5, let's solve now for x. So this will be 5. This minus 7, we're moving it across, so it's going to become plus 7, right, equals to 4x. 5 and 7 is 12. 12 is equal to 4x. So what would x be? X would be equal to what? 12. 12 over, which is 3. So we solve for x, okay?
divided by 4.
Right. So yes. So you could write it out, but for the interest of time, I'm just gonna put the answer, okay? Because we know 12 divided by 4 would be 3. So that is B. Let's know, because we still have time and I might take a little 5 minutes extra. Let's look at how to do this particular question. And it's a short question, thankfully. They only want us to find 3 things, so we could easily do this question. This is the vectors question on the paper that came this year. And it wasn't a hard question, actually. So I'm very shocked that it came so easy. Vectors, this type of vectors here is what we call algebraic vectors because it involves algebra and vectors. So for students who may not know what a vector is, I will demonstrate for you what a vector is. Let's say that I live in this house and I am located here, okay? And it have a nice straight path that leads to the road. And I'm on the road here right now, right? So this is like your road, right? So a vector could be considered as a line with an arrow. So let's say this pathway, I could take the straight path to go home. You all could agree with that. But let's say this pathway have a dog or something in the yard. They fence it around good, but it have a bad dog somewhere here, right? A dog, right? I'm just throwing a dog there. I can't take the straight path home, so I have to walk along the pathway. This is basically the y path, and this is like the x direction. So every vector generally has an x and a y component for that reason. Now, if we had a lot more time, I would love to go into a lot more details about the analogies over here. But that is what a vector is. A vector is basically something that can be broken down into x and y components. So it has size and magnitude. Another way you can think about a vector is scalar and vector quantities for those who do physics. Do anyone here know the difference between, let's say, speed and velocity? Have you all ever heard the word velocity before? Right, so
Yes,
you might. So what does those things mean? Are they, people use them interchangeably, right? Even things like distance and displacement. These are things people use interchangeably, but they are different. A vector has a size and a direction associated with it. For example, if I say I am walking 5 meters, do you know which direction I am walking in? No.
No, sir.
I just said I'm walking 5 meters. That is what we call a scalar, because we don't know the direction. If I mention to you, though, I am walking 5 meters northeast, I have a magnitude which is 5 meters, and now I have a direction northeast. That instantly now becomes a vector. So that is just an introduction to what vectors are. The good news is you don't need that type of vectors. I just wanted you all to know, for those who never think about vectors like that, I just wanted you to have a reference point. Okay? This question, though, the vectors we're going to be using here is a little different. So let's look at how to do this question. It's the last question we could do, because, you know, time is a little short, but we will finish this question. It won't take us too long. So let's look at it. They gave us some information here. In the diagram below, because, you know, normally we just talk for a few minutes after. Let's just do all the question and finish the paper. And if you're in the diagram below, O, P, and Q, O, P, and Q is a triangle, as you can see. A, R, B, A, R, and B is a straight line, right? And they say that there. A, R, B, and A, O, Q are straight lines. So where's AOQ? AOQ, that's the line on the bottom. They are straight lines. So these are two straight lines we are seeing. B is the midpoint of P and Q. That means B is exactly in the middle of P and Q. R is the midpoint of A and B. R is directly between A and B. OR and RP has a ratio of 1 to 3. So if you look at this here, OR and RP has a ratio of 1 to 3. That is where we're going to spend a minute or two on to explain what that means. Because of time, I'm going to do a little drawing here, and I would like for you all to tell me if you all, I'll show you all, I'll explain it from the drawing. What does a ratio of 1 to 3 means? You notice, remember, it said OR is 1, all right? And RP would be, remember, look at this, OR to RP is a ratio of 1 to 3. That means OR is 1 and RP is 3. That is just the distance. So if I divide this thing up in like this here, OR is 1 unit basically, and look at the distance to go from R to P. Isn't it 3 of these portions? So this is 3.
Yes,
So
yes,
if we were to add up this ratio, 3 and 1, we get 4. Okay? So that means, to make life even simpler, That means if we divided this distance from O to P into 4 pieces, this is piece 1, piece 2, piece 3, and piece 4, into 4 pieces, which we have here. One portion is OR, and the next 3 portions is RP. This comes a lot in these types of questions, these types of ratios. And this description I gave here is exactly how you will analyze a ratio in a question like this. Always will think about it like that. And look at this. They say OP is given vector OP. Now look at this. This is important. OP means you're starting from O and you're going to P. And that is represented by 4A. What that means for us is if I'm starting at O here and I want to walk to P up here, right? That distance is 4A. So isn't that simply a would be in this portion, a would be here, a would be here, and a would be here? Isn't that still 4A? A, and A is still 4A. So to go from O to P up there, that is this what I drew here is 4A. That is what that means so far. That is what they gave us. They gave us OQ as well, but we'll get to that soon. 8B. So I'm going to write that down here. They said O to Q is 8B. Okay. So where's O to Q? That's down here. And they said that is 8B. So the bottom of this triangle is 8B. I'll fix that a little better. 8B. So the bottom of the triangle is 8B. Because with vectors, direction is important, I'm going to draw this yellow arrow to indicate I am going from O to Q, because that is what my vector had, O to Q. That is important. Because my question also, for the first one we did O to P, I'm going to put an arrow going upwards from O to P as well. Okay, I'm just doing it like that. We'll see why those things comes in handy. The question wants us to do, firstly, find in terms of A and or B in its simplest form. What is vector PQ? Vector PQ is basically you're starting from P up here and you want to go all the way down to Q. So what you do here is, because this is very easy, you always in a question like this, where we have to find a matrix, draw a line to indicate what you're going to do. If you want to go from P to Q, you have to imagine that your pathway here is blocked. So you need to find an alternate route. Wouldn't a good alternate route be going down this direction and going across here?
Yes.
That's the alternate route.
Yes,
Now
sir.
remember this is for A, remember that. So in terms of A and B, can you see that in order to go from P up here, right, from P up here to Q down here, we need to go down this 4A and go in line with the 8B, because 8B is between O to Q. So we have to go down 4A and go in line with 8B. Because, remember the importance of the arrows. Because I am going to go from P to Q, I need to go in the opposite direction of the vector 4A. I will simply just use a different sign. I will use negative 4A. So this answer for PQ, the way you write it is you need to go minus 4A, because remember, the vector 4A is in the upward direction. That's what they gave us. But we need to be going down the hill, which is in the opposite direction. So we change the sign from positive to negative. So it's negative 4A, and we are going in the direction of 8B. So look at our arrow. Our arrow is pointing, our arrow down here is pointing in the same direction as our vector 8B. So we could keep it as positive 8B plus 8B. Or you can rewrite it as 8B minus 4A. That is the answer for that first question. Okay? That is how to do these types of questions. If you are finding pathways, and if you change something in a path, if you go in the opposite direction of the vector, you change the sign.
So you're using the difference in ratio.
Yes, you use it. Well, the difference in the, well, not really a ratio as yet. This ratio, that 1 to 3 ratio we saw there, is going to come back to play for the next part we're going to do actually. So this here, yes?
Question. Do you not lose marks if you do the equation? Like if PQ is equals to PO minus OQ? Would you lose
Yes.
marks if you
Yes, I like how you stated that. I don't think you would lose it because it's a 1-mark question here. But in reality, that is what you did. You went from P to O, and then you add that from O to Q. So that is true. You should put it. You should write exactly what you did. Huh? I would do that to be safe. But because of time and I want students who still looking at it to at least get some marks in these questions, at least stick with the, if you're running out of time in the exam too, stick with the letters. If you just have to write something, write the letters like that. Okay, but yes, you should put it. I don't think you would lose marks in this case.
I'm not seeing any arrows on the diagram, so how you know the line OP going up instead?
Okay, that's a good question. And that is where we'll end it. So I'll explain that. And you see the other 2 questions, we'll be using the same concept, but I will post the answers for the other 2. Because of how time ran out, I'll post the answers for the other 2 with the document. But the good thing is, this question that she asked is the most important question you can ask about this topic. So let's answer that question. All right, so the question is, how did I know this arrow is basically pointing upwards, the yellow arrow? Isn't that the question?
Yes,
how do I know that? Let's look at the vector. This vector is OP. So I have to, that means I'm starting at O and traveling upwards towards P. That is why the arrow is pointing up. If this was PO, then this arrow would have been, that means I would have to start from P and go down to O, so this arrow would have been downwards. Do you understand now why this arrow is pointing in the upward direction? The first letter is O, the second letter is P. So I'm starting at O and ending at P, meaning that I am going in the upward direction, so I'm pointing this arrow in that direction. Does that clear it up? Let's look at the other one too.
So I have to look at the order in which they put the letters to know
yes.
which direction I go in.
Very good.
Okay.
Let's look at this one here. Let's look at this one quickly. OQ. So the first letter is O, the last letter is Q. So because it starts at O and ends at Q, my vector is going to be in the direction of the arrow from O to Q. So that is how these yellow arrows are important. When you're doing this question, use arrows a lot. All right, it would really help you. This is where I will have to take leave, right? It's 8:07, roughly time. But we could discuss, you could ask questions. I will post the solutions for the last 2 for you in detail. I will draw diagrams and stuff so that you will see the answers, right? But it will be the same thing we're doing here. If you're drawing arrows, you figuring out what path to take in and using the values based on the pathway. So I know I have to post some stuff for you. I have to post a video on circle theorems. No, not circle, something, I can't remember. Something you asked me to post a video on. And I told you I'd post it. Bearings. Okay, I'll sine and cosine rule. I'll post the video for you. I'll post this document tonight so you'll have access to it, and tomorrow I'll re-upload again, like what I always do with answers to these last 2 parts here. And I would have brought us to the end of this document, right? Time, it was good. I believe that you all still had a deep analysis in this matter of a few hours that we had each day. Right? Do we have
so I have a question.
Yes.
Class was very good today, but the only thing is with the cosine and sine rule, like I would plug in exactly what you have, and then I feel like if my answer is off by a few degrees, and I don't know if it's my calculator, I have a sharp.
All right, just now, let me see. I can answer that. So guys, at the end of the class, yes, anyone has questions, something you all can ask now. Yeah? Let me see if I could clear up that for you quickly. That would have been day 3, right? So let's see. The sine and cosine rule question, right? Was it the cosine rule calculation or the sine rule calculation?
What was the sign calculation?
That's the cross multiplication.
Yeah.
All right, just now. Let's see if we can talk about that quickly. Yeah, that would be here, right? That is this calculation we're talking about here, right?
Yes, sir.
All right. Which part in it you didn't get through it?
I
From
think
where?
when we started having to put it in the calculator, like to get the
Okay. Yeah.
yeah,
So
that kind of.
the 0.62, you wasn't getting this when you plug in this portion, probably.
I got 0.6. Hold on.
0.67.
0.61. Well, okay, 62. Yeah.
Okay, no, that good, because most likely you probably had made an approximations at some point. Did you actually work anything, like did you find sine of 83 approximated or anything along the way?
Yeah.
Right. Because you did that, you will get a little approximation error here. Because if you put this whole thing into your calculator, you are going to get the exact value for sine of 83. So it will give you a more precise answer here. But because I had a feeling you would have done it. That's why I asked. That explains why you would have gotten it. But you would lose marks for that, okay? Because you would have your work in that you did that approximation. You wouldn't lose any marks for it. You would when you see your answer was very close to this as well. So your angle would have been closer as well, and that's the point. It will still work out for you. Okay, so
So I got 38.07.
That's, and you did your own working, right? That's still good.
Yeah, I did instead of having how you had it and then equal to sine A, I said A is equal to sine inverse of everything.
So you just find sine inverse of the whole thing. And you are going to get a more precise answer than me, because I had approximated this here.
Yeah.
So I would have my answer would have a slight approximation error. By you finding sine inverse of everything, your answer will be more accurate than mine. So that's actually better. That's a better technique. But I wouldn't put that on paper here because I would probably confuse some students. But that's a better technique actually for the exam.
Okay, so cool.
Yeah. Right. So guys, this was a wonderful past few sessions. I hope you all learned something from this. And yeah, if you have questions, okay, yeah, you can ask a question.
Sir, good night.
Good night.
I just wanted to know if the information of the classes will still be on the classroom chat.
I believe that
the classroom will be still available.
I think the classroom would be available, and all the recordings from the meetings are on YouTube. So you will also have access to the recordings. And yeah, I believe the documents should be on the classroom. But just to be safe, you should download it and keep a copy on your tablet or something in a folder, or on your computer in a folder. But I think you would still have access to the classroom. I believe you should still have until the exam. Yeah.
All right, sir. Thank you.
Yeah. Yeah. Thank you for the comments, sir. Yeah. Oh, I messed up the recording.
How long are you keeping the live videos up for?
I think I'm not too sure. I would need some I wouldn't be able to tell you that one. But I think it might be up on the YouTube channel indefinitely. I believe for sure it would be there until you write your exam. I could probably say that with some confidence. Okay?
Okay, thank you.
Okay, let's see, your answer has been posted here. The live videos will be up indefinitely. All right, so that's the answer for that question. All right, so I'm going to stop my presenting my screen. I don't realize it's still presenting here. All right, I'm going to stop the recording, but you all could still ask your little questions. I know it's the last session, and you would probably want to clarify a few little things. So you could ask your questions for like a few more minutes if you want. Yeah, guys, you all take care and good luck with your exams. I want to wish you all best of luck. Okay, thank you for the good comments. And I'm going to end the recording here.